Now we'll talk about trigonometry. Trigonometry is chapter 8 in the NCERT textbook, and the word trigonometry is derived from three Greek words that are tri, gon and metron. Now tri means 3, gon stands for sides and metron stands for measure. Now what is a figure that has 3 sides? Yes, it's our old friend the triangle. So trigonometry basically means the study of sides and angles of a triangle. Now we've already seen in our previous chapter on triangles that the right angle triangle has a lot of uses in our daily lives. Like the example we saw, that of a ladder being stacked against a wall forms a right angle triangle. Also, if you are looking at a tall tower or something like a Qutub Minar from the ground level, the line of sight forms a right angle triangle. This one here. Now this top of the Qutub Minar could have been a bird or an aeroplane or just a planet or any other celestial body. So we see that the right angle triangle has a lot of applications in our daily lives. So it's very important to study the right angle triangle, and trigonometry does just that. So trigonometry is the study of sides and angles, specifically of a right angle triangle. Now let's look at a few examples. Now let us suppose that here there's a tall building and this is the ground, and there's a small ant here who can lift her head only up to an angle of 45 degrees from the ground. So she can lift it a little lower, but the maximum that she can lift it to is 45 degrees. So that means her line of sight would be something like this, if this angle with the ground is 45 degrees. If we observe carefully, we see that she can only see up to this level of the building. If she has to see at the top of the building where her friend is calling her out, she has just one option: she will have to move back. So when she goes back, again, say till this point, she can again lift her head only to 45 degrees. That means if this is the line of sight for 45 degrees, she would be able to see only up till here. So she has no other option but to go back. And when she moves back further, say up till here, and this is her line of sight at 45 degrees, now this is the time when she can see her friend right at the top of the building. So from this example, we see that when the distance from the base of the ant was small, she could see only up to a smaller height. When the distance from the base increased, she could see much higher. And finally, she had to move quite far back to see till the top of the building. So when the angle is constant, we see that there is some relationship between the sides of a right angle triangle. Let's take another case. Suppose we have a right angle triangle. Say this is our right angle triangle ABC, right angled at B, and this is some angle. Now for simplicity, let me assume the lengths of these sides. Say AB is 4 units, BC was 3 units. So can you find out AC? Yeah, by the Pythagoras theorem, we'll be able to find out AC. This will be 5 units because 5 square is 25 is equal to 4 square 16 plus 3 square 9. Now let us take any point on AC. Say the point is here. Let us call it point P. Now when I drop a perpendicular from this point P onto AB such that it meets here at Q, this is perpendicular, so angle Q is 90 degrees. We can see that triangle PAQ and triangle CAB are similar because they have a common angle, angle A, and these angles are 90 degrees. So by the AA similarity criterion, PAQ is similar to CAB. Once we know that these two triangles are similar, the ratio of their sides, let's first say CB for this triangle. So CB, the corresponding side for the smaller triangle PAQ would be PQ, will be equal to, let's take the hypotenuse for now, so that would be AC or CA, and the corresponding side would be PA. So here PA. So we have this relation because the triangles are similar. This in turn means PQ by PA is equal to CB by CA. I just transposed these two terms. So we have this relationship. Now if we look carefully in the triangle that we had drawn, we see that PQ is this height while PA is this hypotenuse and CB is this height and CA is this hypotenuse. So CB is nothing but 3 units and CA is nothing but 5 units. So the ratio remains 3 by 5 wherever this point PB, even if the point P was here or if it was here and we had dropped a perpendicular, PQ by PA would have remained constant. So for a particular angle, angle A, let's call it theta for now, we can see that for a constant angle we have a constant ratio of sides. The ratio remains constant whatever be the size of the triangle. Only the angle needs to remain constant. Now you must be wondering that why are we considering only this angle? We know that in a right angle triangle, one angle is 90 degree. So the sum of the other two triangles remains constant. So if one angle is theta, one angle is 90 degrees, the third angle is x, then we will have x as 90 degrees minus theta. So if this angle was x, we can say that this angle is 90 degrees minus theta. So if theta is constant, this angle is also constant. So the statement that we just made still holds true. So for a constant angle, we have a constant ratio of sides. Both these examples that we took prove that. So we see that the ratio of sides of a right angle triangle only depend on the angle, and we usually represent the angle by the symbol theta. So ratio of sides only depends on the angles, and these ratios are called as trigonometric ratios. We'll talk in detail about trigonometric ratios in the next session. I know that a lot of us have apprehensions about trigonometry, but I don't think it's that difficult. Actually, I think it's a lot of fun. So let's explore it more in the next coming videos. Bye.